Alright, let's work the next problem. A flower pot falls from a windowsill 25 meters above a sidewalk. How fast was the flower pot moving when it strikes the ground? How much time does a passerby on the sidewalk below have to move out of the way before the flower pot hits the ground? Again, this question comes from your notes. So, we're going to draw ourselves a picture. Okay, here's our windowsill, and here's the sidewalk below. And we know that the displacement between those 2 points is 25.0 meters. Okay, let's see, a flower pot falls. It was not thrown. Okay, so let's draw ourselves a little flower pot here. And if this flower pot falls, then we know that its initial velocity when it fell is 0. Okay? And we know that the time that it's falling, the whole time that it's going through its motion of falling, it's a free-falling object. Well, if this object is in free fall, then we know that the acceleration due to gravity applies. Alright, so let's put that in here. The acceleration due to gravity is negative 9.81 meters per second squared. Alright, so we know 3 things about the motion, which means we can solve for the other 2. The other 2 things that we could figure out here would be the final velocity and the time. Those are the other UAM variables. And it just so happens that that's the 2 things that it wants to know. So we're in luck. Alright. So let's see here. Why don't we figure out what the final velocity is? We've got final velocity equals initial velocity plus acceleration times time. That's one of our equations. Unfortunately, we can't use it because it's got time in it, and we don't know that yet. This equation's got 2 unknowns in it. So we have to pick an equation that's only got initial velocity, acceleration, displacement, and final velocity. So that one looks like it's going to be final velocity squared equals initial velocity squared plus 2 times the acceleration times the displacement. That'll work. Now we'll have to take the square root of both sides to cancel out our square there. So we get final velocity is equal to the square root of the initial velocity squared plus 2 times the acceleration in the y-axis times the displacement in the y-axis. So let's plug things in then. The initial velocity is 0, so that part goes away, plus 2 times the acceleration due to gravity. That's going to be negative 19.62 meters per second squared times, since the flower pot is falling, we're going to have a displacement of negative 25 meters. Okay, so we can go ahead and put a little negative sign right there. Alright, so these 2 negative signs here and here will cancel out once we multiply those together. So let's do that and get our answer. So I come up with 22.14723 blah 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 meters per second. And let's just check those units real quick. Here we get meters per second squared times meters over 1. So this meters is in the numerator, and so is this one. So that's going to be meters squared per second squared. When you take the square root of that, you're going to get meters per second, which is the correct unit for velocity. So we've set the problem up right. Now let's do our sig figs. We've got 3 significant digits in our given, and that's it. So we have to have 3 sig figs in our final answer. So there's the first one, the second one, the third one. This 4 does not do anything to the 1, so our final answer then is going to be 22.1 meters per second as our final velocity, and since the object is falling, we have to include a negative sign because velocity has direction. So we're going to box that answer. Don't forget that negative sign, it's important. Okay, so now we want to figure out the time. Okay, so final velocity equals initial velocity plus acceleration times time. That seems to be the easiest equation to use here. Since we just figured out what our final velocity is, we can use that number. So let's do that then. Let's resolve this equation for time. We're going to subtract the initial velocity off of both sides first. So you get final velocity minus the initial velocity equals acceleration times time. We'll divide both sides by the acceleration, and that means that time is equal to the final velocity minus the initial velocity divided by the acceleration in the y-axis, of course. Okay, so the final velocity, we have to use every digit the calculator gave us, no rounding in the middle of your question. So 22.1472345903501. That's all the decimal places my calculator gives. Minus the initial velocity was 0. And then divided by time, negative 9.8, not time, acceleration, divided by negative 9.81 meters per second squared. Now, we are going to have a positive number on top. You've got a negative number on bottom, which is going to give us a negative answer, but you can't have negative time. Remember that this negative sign is not mathematical, it's directional. So we can ignore that on time because time doesn't have direction to it. Okay? So let's plug that into our calculator. Alright, so I get that time is equal to 2.257618, so on and so forth. Again, we can only have 3 sig figs in our answer, so there's our first 3. We look and see, does this 7 do anything to the 5? And indeed it does this time. So we get 2.26 seconds as our final answer for the time that a passerby has to get out of the way before that laptop crashes or that flower pot crashes into the ground. Okay? Thank you for learning with me, and I'll see you in the next one.